Welcome to our panel on melting glaciers, lake formation, and the implications on the Himalaya. This is part of our webinar series in which we are looking at the Himalaya as a hotspot, not just as a climate warming hotspot, but also a geopolitical hotspot, and how the two are interlinked and how they have ramifications for all the people who live in these mountains, as well as the billions who live downstream. This session has a presentation by Alton Byers, who is a senior researcher and faculty at the Institute of Arctic and Alpine Research at the University of Colorado at Boulder. He's been researching climate warming in the Andes and the Himalaya for the last 15 years, and especially with a focus on the impact of climate warming on glacial lake outburst floods, or GLOFs as they are known. And he has explored new glacial lakes in the remote parts of Nepal. And he has also investigated historical GLOFs in the Kanchenjunga region and elsewhere. Alton will speak for about 25 minutes with some slides. And if you have any questions, please type them into the Q&A box, and I'll try to catch some of them after Alton speaks. This talk is packed with information, and we have limited time. So let's get right to it. Alton.
Let me unmute, start video, and share screen. And there we go. Today, I will be speaking about melting glaciers, lake formation, and implications for the Himalayas in the next 20-25 minutes. So I'm going to jump right into it because we have a number of things to cover. And the first thing we can do is ask, well, what's the issue? What's the problem? And the problem is warming trends and climate change, which have had a particular impact on the glaciers of the world and in the Himalayas as well. So we can look at old photographs such as this. This was taken of the in 1955 of the Imja Glacier in the Mount Everest area, and then we look at it again today. We see that what was a debris-covered glacier 60, 70 years ago has now become a large glacial lake. And the concern about these lakes is basically the amount of water that they hold. In this case, Imja Lake holds about 80 million cubic meters of water. And the concern is that if that water is unleashed suddenly, it can result in a flood, what they call a glacial lake outburst flood, or a GLOF, and create enormous devastation downstream. So let's look at this lake from another angle. This is Imja Lake again. And let's look at the different components of a glacier and a glacial lake. And first of all, the remaining glacier. Now, what we call this is the glacier terminus, because it's all that remains of a glacier that even 70 years ago filled that trough to capacity. But every year it recedes, it calves about 50 meters of ice off every single year in the form of icebergs that float in the lake until they melt. And it will continue to recede until it's at the base of those mountains behind it. Then we have the lake, and as I said, this is quite a large lake of some 80, 85 million cubic meters of water, which is held in by a terminal moraine of unconsolidated material, rocks and rubble and soil, as opposed to the lateral moraines on each side. But these terminal moraines are all that's holding in all of that water, and they were not designed to do that. Okay, so the fear is that in some cases, they might collapse on their own and a flood will commence. But usually what happens is that ice in the form of an avalanche from the mountains above falls into the lake, creates a surge wave that breaches that terminal moraine, and then you have a flood downstream. And we've had about between 24 and 35 major glacial lake outburst floods in Nepal, mostly since about the 1960s. Now, as I did in the first slide, one way to appreciate what's happening is in the high world, the high mountain world, is through repeat photography. And all that is going back and finding the photographs of the first climber scientists to an area, in this case, Fritz Muller and Erwin Schneider in the Khumbu region, finding their photo points and then replicating their photographs from 70, 80 years ago, and looking at the differences. And the reason I'm showing this series of photos to you is I always found it fascinating that when these climber scientists were taking their photographs back in 1930, 1940, 1950, the number one thing on their mind was the return of the Little Ice Age. Okay, they were scared to death that once again the world would get colder and glaciers would once again advance and destroy villages and cropland, just like it did back in the 1800s. And in fact, the exact opposite happened. So what we see is that hundreds of glaciers, small glaciers up at the higher altitudes, like this one on Kong Mala, are now gone. Now here I'm using repeat photography, a slice in time between 55 and 2015. But if you add remote sensing to this, you can come up with a pretty good package to appreciate the scale of what's happening. Let's look at this glacier. This is the Khumbu Glacier in 1955, taken by Erwin Schneider, a climber cartographer from Austria. This is the glacier that Hillary and Tenzing walked up beside before they went up to climb Everest for the first time in 1953. Now, I retook this photograph in 2007, and I could already detect some change in terms of the formation of superficial meltwater ponds. If you look at it last year, it looks like it's accelerated in terms of its loss of mass, the ablation, etc. This is also probably one of Khumbu's next major glacial lakes. And the reason we think that is because the slope of the glacier is so low. If the slope is 2 degrees or less, you're probably going to get a glacial lake form because the water will melt, it'll pond, it'll coalesce, form a lake, a larger lake, etc. Just like we saw a few minutes ago in Imja Lake. This has a very low slope. It will probably form a glacial lake within the next 20, 30, 40 years. Other glaciers with a higher slope that we'll see in a moment will not form glacial lakes, but this is probably one that will form in the future. Now, it's just not the glaciers that are changing, it's society, it's cultural landscapes that are changing in the high mountains all over the world. So if we look at this photograph of Namche Bazaar in 1973, and then we look at it today, there's been a tremendous change in the cultural landscape, in this case in the form of lodges replacing traditional architecture. And this is driven primarily by tourism. When that first photo was taken by me in 1973, there were less than 1,000 visitors or tourists to the Khumbu. Well, a year ago, pre-COVID, when I was there were 60,000 tourists, not counting support staff. So that's like 150 non-Sherpas visiting the Khumbu every year. Now, in terms of water, they're also having some water issues here because each of those lodges has a septic tank, and all the septic tanks leak. So they contaminate the groundwater. The traditional sources of fresh water are now contaminated, so they've had to look elsewhere for fresh water. Likewise, here's the village of Kumjung that my wife Elizabeth and I lived in for a year in the 80s doing my doctorate research. It looked pretty much like that back in 1984, but now it looks more like this. Again, a direct result of the positive economic side of tourism. However, they too are experiencing water shortages, more related to climate change and changes in rainfall and snowfall patterns. So traditional springs are drying up. And what they had to do back in 2013 with support from the government of India was to pipe in water from 10 kilometers away, from a glacier 10 kilometers away. So many villages are having issues related to water as a result of climate change, in addition to the impacts on glaciers. Now, with the good comes the bad. There are studies show that about 400 tons of garbage come into the Khumbu every year. That's plastics and bottles and tin and all sorts of things that never goes out. And that's been happening for decades now. And what people do is they put it into pits, what they have done, and burn it and bury it. So that what's that doing? That's poisoning the air. It's contaminating the water. So there's another water issue that is facing places, high mountain areas with high levels of tourism. We have a paper coming out in Mountain Research and Development shortly with the results of our study, where we try to help the local government develop a solid waste management plan that you may be interested in, and I can provide you with that link when it comes out. Okay, how about some good news? This is the Tengboche terminal moraine back in 1955. And if you look at the slopes to the left, you can see they're bare and heavily terracetted from cattle. Yeah, I came back in 2007 and took the photograph, and look, we got trees coming back. And this is representative of a trend throughout Nepal and much of the Himalayas, in contrast to the doom and gloom scenarios of the 1970s and 1980s about the degradation of the Himalayas. Trees are coming back. Now that's in 2007, and look what the same scene looks like last year. So this is really good news. They're coming back for a number of reasons. It's very complex, but probably related to changing lifestyles, changing livestock populations, the influence of the national park, of traditional management systems, and climate change, warming trends, which may be more conducive to tree growth. But regardless, a continuous cover of vegetation, as you know, is good for water. It intercepts rainfall, it promotes infiltration, it promotes recharging of groundwater supplies. So this is good news in the face of other uncertain news in the Khumbu. So Kunda said that you were interested in the Andean Asian exchange that I was leading back in 2011. And back then what I did do was to bring researchers from the Andes who had 50 years of experience in controlling dangerous glacial lakes, as well as colleagues from Pakistan, China, India, the US, not just to sit in another conference in Kathmandu, but to actually go up to Imja Lake and exchange experiences with themselves and local people while they were at Imja Lake. And I got the idea for this when I was working in the Andes. This is the Cordillera Blanca and the city of Huaraz in Peru. And two things struck me while I was working there. One was how the Andes had experienced the impacts of climate change so much earlier than the Himalayas, for various reasons of altitude, latitude, clean type glaciers, but their glaciers were receding and forming dangerous glacial lakes way back in the 1920s and 1930s. So that in 1939, Hans Kinzel, who was a famous Austrian geographer, who also worked with Erwin Schneider that you've seen earlier, told the government that they should be careful of these large glacial lakes that might burst and cause devastation downstream. In 1941, this particular lake, Bacococha, indeed burst and went through the city of Huaraz and killed about 3,000 people. Now, there were two more glacial lake floods throughout the 1940s that killed a total of 10,000 people in this region. So you can see they're pretty significant events. Our study in this area in 2014 showed that if this lake burst again, and it is now 17 times the size it was back in 1940, it would kill approximately 32,000 people. But regardless, what the Peruvians did was get together, survey all of their glacial lakes in the Cordillera Blanca, and then on their own develop the methods and techniques to control or reduce the danger of these glacial lakes, either through technologies as simple as a ditch to something as sophisticated as drilling a kilometer through solid rock, and through a system of valves being able to lower or raise the level of the lake at will. So we thought that this sort of knowledge should be shared with our Asian colleagues, which we did in the course of this 2011 expedition to Imja Lake. And here we are speaking with local people. That's one of the themes of my presentation you'll hear again and again, which is the need to involve locals in your field-based research. From there, we formed the High Mountains Adaptation Partnership, or the HIMAP project, with support from US aid. And in 2013, I was now able to bring the Nepalis and the Pakistanis and Chinese and Indians to Peru. And here we are, right in front of that same lake, Pacacocha, the one that is so dangerous, above the city of Huaraz to this day. And it was really a wonderful experience to see this, something like this, where Karma Toeb is off to the left, had just finished lowering a lake in Bhutan, sharing experiences with Cesar Portocarrero to the right. Cesar had worked for 40 years with the Department of Hydrology in Huaraz and had lowered some 18 different glacial lakes. And in fact, we had him write a handbook on that very topic if you have any interest. But there was a lot of energy, a lot of really good information sharing as a result of this. In fact, the UNDP kept Cesar on through a series of consultancies with their project with the government of Nepal to lower Imja Lake, the one we've been seeing since the beginning of the presentation, by 3 meters. And this was accomplished by the Nepal Army and the private sector and the government in 2016, where Imja was lowered by about 3 meters, replicating a project in 2000, 16 years earlier, in the lake due west of Khumbu, Shoropa, where they had lowered that by 3 meters. So Nepal has lowered two of its lakes, both by 3 meters. So something to be thinking about as I finish this presentation is, why 3 meters? It's kind of an interesting story behind that. So it wasn't just exchange and collaboration, but we were also doing some serious research on Imja and other glaciers in the region. And that gave us an opportunity to routinely share the information we were gathering with local people. And that gave them, put them in a position to make better decisions, more informed decisions about how to deal with the changes they were experiencing related to climate change. In this case, developing their own LAPA, which is the Local Adaptation Plan of Action. This was finished in 2014 in the Khumbu and 2015 in the Cordillera Blanca in Peru. And that's Jorge Richarte off to the right, the director of the program for the Mountain Institute. Okay, let's go to our first case study of a GLOF. And this is about the Lungmale GLOF in the Burun Valley, which is in far eastern Nepal in a region called the Makalu Burun. It's actually a national park now, the Makalu Burun National Park. One of my favorite areas in Nepal, as I lived here for 2 years back in the mid-90s, helping to set up the national park. Now that's Chamlang, that flat mountain in the distance, and to the right is Makalu, the 5th highest mountain in the world. If you went just over the crest of those, you'd be back in the Everest region. But this happened due east of the Everest region. When we were actually doing research in Khumbu, when we heard there had been a flood in the Burun Valley, but it's so remote that nobody knew when it happened or why it happened. So we were able to take a helicopter over the south West Col and the Sherpani Col into the valley and check it out to see if we could determine what happened. Now, here's a video we took of the helicopter. Let's see, here it goes. And I just wanted to show you what it looked like. We didn't know where this had come from, but here we are flying up into a basin. And I'm going to hop ahead here. Oh, wait a minute. I have to work on this computer. I've got, okay. Okay, this is just a week after it happened. I wanted to show you this. Look at how, remember back the first trough we saw. This is very similar, but that's the Langmalay Lake. You can see the lateral moraines. You can see where the terminal moraine had been breached, and also notice how small it is. It was really quite a small lake for the amount of damage that it did. And also notice how much filling is inside of this trough. When you read papers about glacial lake outburst floods, they've normally been written 20 years after the fact, and they miss things that we were very fortunate to see by getting there within days of this happening. But for some reason, that trough had been filled up. I'm going to have to manipulate things here. And okay, and there it is, the glacial basin. Let's jump ahead and look back down again. See if I can move this over. Now we're looking back down again, and we didn't really know what caused this. Why is this all so dirty up here? And I'll just jump ahead and to make a long story short, I came back about a week later with one field assistant. We spent 3 weeks researching this, trying to figure out what happened. You can see something major happened. Dust was covering the entire valley. Massive icebergs had broken off from some major explosion. Look at the size of the rocks. Look at the debris here. And what we found over time was, here was the reason. Yeah, half or a quarter of this mountain, Saldim Peak, had broken off and fallen down onto the glacier. That was the source of this massive explosion that created all kinds of heat, that melted the ice, that then fell into the lake and created this glacial lake outburst flood. And this is a direct result of changes in permafrost. I was contacted after our paper on this was published by Wilfred Haberle in Switzerland, and he said, do you realize what happened? And we really hadn't, but he had done extensive study on changes in permafrost in the Himalayas to show that this was happening with an increasing frequency, in addition to avalanches causing glacial lake outburst floods. So let me get my thing here. Okay. Okay, now what does an actual flood look like? I really wanted you to actually see what these things look like. So I hope these videos are coming through. But a climbing group was in the valley the day that the flood happened. And you can see, here they are. That's what the flood looked like seconds after it happened. You can see it's already washing away tea houses. It's carrying down trees and all sorts of debris from above. Now it's being rechannelized down below. And then as you can see here, let's go back here, it carried away the tea house. And I spent many nights in that tea house, which was unfortunately built in a floodplain, and which is the reason why it was carried away. Now we did, like I say, spend about 3 weeks researching this, and the point I wanted to emphasize here was two things. Number one, the value of interdisciplinary research, starting with talking to local people, getting their perspectives on what may have happened, combined with remote sensing, flood modeling, as well as on-site visits are really very, very important to the research process. The second thing I wanted to stress was the importance of getting to the site as soon after the event has happened. Like I said, most studies of glacial lakes have taken place 20 years after the event, and so much evidence has been erased by then, including what people remember about it. So that's just a couple notes about the Langmalay glacial lake outburst flood that was actually started by a landslide. Now, for good news, yeah, there was a lot of destruction because these buildings had been erected in a floodplain, but they had recovered. A year later, we came back on another study. We were studying the impacts of Yartsagumba, or the caterpillar fungus, on alpine ecosystems, and we were able to take these photos to show how resilient the people and the landscape is. Hotels have been rebuilt up on higher ground. Bridges had been rebuilt, in some cases much higher, and even vegetation was starting to come back. This is astragalus, which is the pea family, already coming back on cow pies, but that was 3 years ago, and I bet you it's much larger today. The issues that remain are that dams and hydropower projects continue to be built downstream. This is the Auburn 3 a couple of years ago. By now, there is at least a 70-meter high wall, and directly upstream is this, the lower Barun Lake, very large and a potentially dangerous glacial lake. As it recedes, someday the lake is going to be directly under that ice fall to the far right, and then it's going to be especially dangerous. But these are things that are quite common throughout Nepal, glacial lakes being above large billion-dollar infrastructure projects, and not just Nepal, but lakes in Tibet. There are glacial lakes in Tibet that have flooded and caused destruction in Nepal. Okay, let's go to our second and final example, and those are end glacial conduit outburst floods. That just means the flood comes within the glacier, and the source is conduits or caves that are filled with water. So here's Umesh looking upstream saying, why is this water, why is this flood coming? There's no lake up there, and he's right. But these particular types of floods seem to be occurring with a greater frequency. This is my informal record since 2005. And what happens here is that these floods come from within the glacier. So this is the Lhotse Glacier. It's got a steep slope greater than 2 degrees. That means it's never going to form a lake. But meanwhile, it's ablating, it's losing mass, it's melting, and it's becoming essentially what is a great big piece of Swiss cheese. That is, it's riddled with caves that are filled with water during the warm season, connected to superficial meltwater ponds that can drain quite rapidly, like this one. That's the same superficial pond over a period of 2 days, that in turn can trigger the flooding from one conduit or one cave into the next, until you get the bursting out into the glacier of water. And again, we were walking down the Lhotse Glacier about in 2016, when we actually experienced and filmed one of these. That's the village of Chukung, a tourist village below the Lhotse Glacier. And all of a sudden, out of the glacier, we saw this. So what's happened is the water has burst the ice lenses that were holding in all that water in the cave as a result of a trigger upstream. Now you can see it coming out of the walls of the glacier. This debris-covered glacier is coming out here. It's coming down. It's starting to pool. And the danger is that the village of Chukung is down here to the left. So we were able to cross an ice bridge. I think it's up here someplace. You can see now, several hours later, it's starting to come down, but there's a lot of water that is moving down and ponding, and is a hazard to villages downstream. Now I'm going to show you the ice bridge that we crossed, which is right here. We were able to cross that and get back to the village. But even a couple of hours later, you can see how much water was coming down and threatening this village of Chukung. A year before, there had been a flood like this, the year of the earthquake, and they had built these gabions, which are rock-filled cages, and that prevented further damage to the village. We were then able to retrace the path both the observed and the reconstructed path, and also figure out the source of the flood itself. So there's quite a bit of water. That's over 2 million cubic meters of water that came down and directly threatened the village of Chukung. This is not to say that these floods have only happened in the last 10 years or so. We know they've been happening. They happened 50 years ago. Here's one that happened back in 1955. And I think it's the same glacial or end glacial conduit flood that happened when Fritz Muller was there in 1955. And after the flood, this flood destroyed a number of gata, or prayer wheels, or water-driven wheels. And a large group of Sherpa came to Fritz Muller and wanted to kick him out of the Khumbu. They said the gods were angry because he was doing research on the glacier. Well, fortunately, he was friends with the Rinpoche, shown here at age 14, the Tengboche Rinpoche, who convinced the local people that it was not Muller's doing, and he was allowed to continue his research. But this is just to say that they have been going on, certainly since the end of the Little Ice Age in 1860. They just seem to be accelerating now. And in spite of what you hear down in the cities or what donors say, people are adapting. These are gabions that local people built after the first flood in 2015 that effectively saved them in the flood of 2016. And a gabion is, of course, a rock-filled wire cage. People are also tending to build bridges much higher than they used to. So many other ways that people are adapting. These are just a couple of examples. So we have a number of publications on these two topics and many others that I have talked about. If you're interested, I think we sent you the PDFs before the presentation, but if you want to learn more about the Bruin GLOF or the end glacial conduit flood, we did a study on earthquake impacts on glacial lakes you may be interested in looking at in 2015. We developed our own system of high risk, of identifying high risk lakes, and of course, one paper recently on the benefits of participatory research. So as a take home, just a couple of things I'd like to mention I hope came through from this presentation. And one is that Nepal and other Himalayan countries have clearly entered eras of accelerated glacier and high mountain hazards, and most of them are poorly understood. We've never had to deal with this sort of thing before, so all of this is relatively new, and we keep getting surprises every day, such as the changes in permafrost and the 2017 GLOF in the Barun. Continued interdisciplinary research, I've tried to highlight that. Participatory research, I think it's very important to include the knowledge and experience of local people, and timely research is important. Like I said, it's important to get to these places as soon after a hazard or an event occurs in order to best reconstruct what happened. So that will put us in the best position to understand what are the effective risk reduction management options. For example, when is lowering appropriate or not appropriate? What sort of early warning systems work best? And what about zoning? And speaking of zoning, I think that major damage could be reduced by simply building away from floodplains, like we saw in the Barun. Don't build a hotel in the historic floodplain, or torrents or other indicators of recent hydrologic geomorphic activity. At the same time, I've shown you people are already increasing bridge height and building gabions, etc. And finally, large hydropower projects need to recognize, I think, and plan for these events. And finally, what will help this is more transboundary research and cooperation. That is, sharing of research between India and China and Nepal, Nepal and China, etc., which for various reasons is not always done. But I think we need more of that to put us in the best position. So with that, I'll say thank you very much. And that's it, Kunda.
Thank you, Alton. Great talk. We're getting some questions here. You mentioned communities getting together to adapt to glacial lake outbursts. But what are states doing? And as I mentioned earlier, and also in the previous panel, the Himalaya is also a hotspot for geopolitically, which means a lot of these lakes that are in Tibet or in China flow down into India or Nepal. Is there a system where there can be advanced early warning that, that the lake has burst, you guys downstream, take care of yourselves? I mean, have there been examples of early warning that has worked?
No, I don't know of any examples of early warning. I know examples of floods that have occurred and nobody downstream was notified. To answer your question, yes, there could be systems, early warning systems, effective early warning systems installed, but what's curtailing that is, of course, political tensions. So we have political tensions between India and China and Nepal, and it's just like Deepak Gyawali on your panel said in a recent publication, there's not a culture of sharing. Okay, that's the foundation. And number two, it's exacerbated by political tensions. So it's going to be difficult. It can be done and it should be done. And I hope that we reach a point where there is routine sharing of information so we can build these sorts of early warning systems.
Alton, you mentioned, there's a question here, sorry, there's a question here about 3 meters. You said that you tell us why it was 3 meters.
Okay, so whoever asked that question, will you promise to give them 25 bonus points?
Okay, that's no. George Taylor gets 25 bonus points.
George Taylor. Okay, George, I know George. And the reason is because in 2000, the Europa was the first glacial lake to be lowered. That was lowered by John Reynolds, a British glacier specialist, and Mr. Pradhan. And they lowered it by 3 meters. They had a grant from the government of Netherlands. Well, the research showed it should be lowered by 20 meters. But when they got to 3 meters, they ran out of money. So that's why they stopped at 3 meters. Okay, well then along comes IMJA. And so people automatically said, well, how much do we lower it? They said, well, we'll lower it by 3 meters. Question was why? And the answer was, well, because that's what they did at Europa. Okay, so that's the reason. But it is a little, I think it's a little more serious. Nepal is about to embark on a program of lowering 5 more glacial lakes. And I hope that they don't use a broad brush blanket approach and lower each of these by 3 meters. Every glacial lake is different. Everyone demands its own detailed investigation. The amount you need to lower it is going to differ from lake to lake. So I hope they take that into consideration.
Alton, can you just lower your camera a bit? We just have, I think, time for one last question. And there is one question which I also wanted to ask you, which is, we've talked about glacial lakes as being damaging and as being a bad thing. Are they good? Like, could they be sources of fresh water or energy, hydropower generation? No, we need to see your face, Alton.
Okay.
We're seeing your keyboard. Okay. Yeah. Did you get that question?
Yeah, I did. And that's really a wonderful question because I was talking to Cesar Portocarrero that you met earlier in the presentation. And he said that down in Peru, suddenly people are rethinking the whole subject of glacial lakes, that because of climate change and threats to freshwater supplies, they're now looking at glacial lakes more as reservoirs of future water supply and something to be maintained, something to be conserved as opposed to drained and removed. So I think that that's going to catch on quite quickly in the Himalayas as well. That yes, many of these glaciers are quite dangerous. Some will need to be lowered, but others might respond to some other form of mitigation to make them safer, whereupon you could use the water as backup freshwater supplies or hydropower or irrigation, etc. So yes, that's very important to keep in mind as we move forward with this study.
There's a question here about what message is there for hydropower investors? You showed us the Arun 3 being constructed directly downstream from the Barun Glacier. If that bursts, I mean, all hell's going to break loose right down that river. So, I mean, how should hydropower plants and investments be made in Nepal or Bhutan or anywhere else?
Well, I think that, like anything else, they should be done with a thorough study of the hazards. And to date, most hydropower studies include floods as one of the theoretical hazards, and they build or they design the structure based on the likelihood of floods. However, as far as I know, glacial lake outburst floods are not taken into consideration. So the first answer to that is take into consideration GLOFs and the potential impact of GLOFs, again, both within Nepal as well as in Tibet. Now, to date, a number of projects have been criticized by USAID, the Agency for International Development, and other groups for not including glacial lakes. And that's something that really needs to be included, or as you say, we're going to have catastrophic consequences.
The climate deniers are saying that this is all natural. It was happening after the last ice age or little ice age. And there's also a question here about it. What proportion of the melting or the glacial lake formation is anthropogenic, and what proportion is natural after the little ice age and the warming of the earth, natural warming?
Yeah, well, you're entirely right that the warming trends began in 1860 at the end of the Little Ice Age, but I think the scientific evidence is pretty clear that these increases in temperature began to rise dramatically with the beginning of the Industrial Revolution and emissions, large-scale emissions being pumped into the atmosphere that in turn accelerated heating processes. So, I mean, my own opinion, and this is just me, is that it's 25% natural and it's 75% human induced. And that's why it's so important to be addressing the impacts of climate change now.
Yeah, there's another question here about what proportion do you think of the melting of the ice cover of the Himalayas due to soot particles being deposited on the snow and making them melt faster? So one of it is global, and the other is local, dirty snow melting faster.
Right, dirty snow, but still connected because of, a similar process. I'd say pretty significant. There have been some, I don't know the exact percentage, but I know INSTAAR, the International Center for Integrated Mountain Development, did a study on that. Other people have done studies on that. There have been a number of studies done down in the Cordillera Blanca, and you'd be surprised what a difference that makes in terms of accelerating melting. So that is definitely a factor.
There's a question here about what can be done to actually prevent a glacial lake from being even formed. I mean,
a glacial lake from being formed.
Yeah.
Well, I mean, one thing you could do is in the early stages. Remember, I said that a lake that has a small slope, a glacier that
2 degrees,
is not slope, is going to form a lake. Okay, so let's say we're back in that Khumbu Glacier. What you could do is starting to form a lake right now, but you begin the drainage now. Okay, if you don't want a lake and you've decided, I don't need the water, I don't care, I just don't want a lake because the threat of a flood is too great, you would begin the draining right now. In fact, that's what the Peruvians were doing back in the 50s and 60s and 70s, beginning a draining process early on before it became a large and dangerous lake.
Another question, have glacial floods, these conduit floods, being studied as a threat that may trigger glacial lake floods, larger ones, on low gradient glacier tongues? This sounds like a technical person asking, yeah.
Yeah, are they being studied as a threat? Was that the question?
Yeah, or to trigger larger glacial floods.
Yeah, research, the Brits are doing a lot of study on a lot of work on the end glacial floods. We have a paper out on them, not as much as with the glacial lakes, And a second thing I want to point out, I think I mentioned it, is that these floods are rarely reported so that they don't get the publicity that larger floods get. So I think there's a lot of room we need to know more about these floods. But even more than that, we just need to make people aware of them. I think they already are aware of them, so they don't keep building in floodplains immediately below, because they're very dangerous areas now.
Okay, one last question from attendees, and then I have one last question as a moderator. This one is on how are glacial lakes affecting local wildlife?
How are they affecting
local
wildlife? Yeah, I'm not sure, because you're up really high. You have snow leopards. I know there's snow leopards up there because I see their tracks in the moraines all the time.
Maybe yetis.
Maybe yetis. Yeah, there could be. I'm not sure how glacial lakes affect. I mean, they're good for bird life, migratory birds. It gives them a place to land. But I'm not a wildlife biologist. I don't know if they nest there or what. But probably they're doing more good for wildlife than not.
Maybe one last one also from the attendee, which I also wanted to ask you, which is there I mean, you showed us the Barun glacial flood was triggered by a rock fall from way up in the mountain.
Yeah.
Is this related to climate change and climate warming, as well as the permafrost melts and then the ice that's cementing the rocks together is falling down on glaciers?
Absolutely, exactly. And thank you for bringing that up, because that's the point I was trying to make. According to my friend Wilfred Haberle, who studies these, he's the one who brought it to my attention. He said that was caused by melting of permafrost. And then I spoke with Teji Watanabe, another Japanese geographer that's worked for decades in Nepal, and he said he has observed the same thing. There have been at least 3 instances in the last 5 years of this happening. So, I hesitate to say anything more than that, but it seems like, yes, it is related to climate change. It is one more hazard to be concerned about. It's almost like, it's like when I gave this presentation to ISIMAD a year ago, and when I mentioned this, they looked at each other and said, "Oh no, something else to worry about." So yes, but it is one more.
Yeah, the one on Annapurna 4 in 2014 was quite deadly. It ended up killing 70 people.
Yeah. Exactly.
Okay, well, I think we've run out of time.
Okay.
I was actually going to ask you, is any more research still necessary? We know what's happening. Should we now be planning for adaptation and other action? Or do we still need to study these glaciers?
Oh, I think you'll still need to study them. We really don't know that much about them. And you have to remember that this is a very difficult place to work in. It's high altitude. There's no air up there. It's remote. It's expensive. So yes, I'd say, again, we need as much research as we can, with the caveats of involving local people, using interdisciplinary approaches. But yeah, there's a lot to learn and a lot to work on.
Thank you, Alton. I think a lot of attendees have thanked you as well for an excellent and informative presentation. And also on their behalf and on my behalf and from all the organizers, thank you very much. We've collected a lot of the questions that could not be answered here today. And hopefully we'll be, providing you answers in future material and programs that we have under our project. A lot of the background and theory and papers are actually on our website, so you can go and check them out over there. And we'll also be sharing the recording of this panel as well as the other panels today and tomorrow with the attendees. Thank you, Alton. And I think for the attendees, just a reminder that tomorrow we have another 2 panels. The first one begins at 4:30 GST, Gulf time, which is on the non-human Himalaya. Thank you very much, everyone.
Okay. Thank you, Gunda.